All right, now the last thing we need to talk about in chapter 2. We saw that the climate changes over time from relatively warm to relatively cold periods. Within the cold periods, we tend to have these cycles of glacial and interglacial periods. We're currently in an interglacial. Um, so what causes these long-term patterns, these long-term changes in the climate? Well, the primary thing is what are known as these Milankovitch cycles. And that is, they're named after a person named Milankovitch, who sort of figured that they exist. Um, the first one has to do with Earth's orbit around the sun. Um, and this is sometimes described as the eccentricity of Earth's orbit. Now, this image is exaggerated, but what happens is the Earth's orbit becomes more and less elliptical. At times it's almost close to being a perfect circle around the sun, and then other times it becomes, excuse me, more elliptical over time. Um, and so you can see that as the Earth's orbit changes, when it's more of a circle, of course, throughout the year the Earth will be equidistant from the sun. But when it becomes more elliptical, there will be times during the year when the Earth is somewhat further away and somewhat closer to the sun. Okay. Now, the angle of the Earth's tilt changes over time as well. Currently, we're at about 23.5, but the range is anywhere from 24.5 to about 22. Um, so you can have times where if you're at your maximum tilt um, at the winter solstice, essentially the northern hemisphere is tilted further away from the sun than it would be otherwise. Or when it's at its minimum tilt, there'll be less tilt away from the sun. So that can influence the extremes of the seasons. Another one that has an impact to a certain extent has to do with the what you sometimes describe as Earth's wobble. Oops, I did that the wrong way, didn't I? Earth's wobble. So, as you know with the top, when you spin it, at first it's sort of upright on its axis, spinning around really fast, but as the spin slows down, the axis is no longer pointing up, it's sort of rotating or wobbling, if you will. And so that's what Earth does. It wobbles on its axis. What does that mean? Well, so currently, um, on around December 21st is when the Earth, the northern hemisphere, is tilted away from the sun the most. But what's happening as the Earth wobbles on its axis, that day shifts. It slowly becomes later and later in the year when you have your maximum tilt away from the sun. So what this means is slowly, and you can see this is about a 22-year cycle, the seasons shift to being later and later in the year. Um, so we generally think of summertime now being June, July, and August. Well, at some point in the future, thousands of years, northern hemisphere summer will essentially be in September, October, or November, or then October, November, December. So it takes 22,000 years for it to go through a complete wobble on the axis. So essentially, in about 11,000 years, the seasons will be completely reversed. That is, summer will be occurring primarily in December, January, and February, and winter in the northern hemisphere will be happening in June, July, and August. Um, all right, so um, because the Earth's orbit is not a perfect circle, it's on around January 3rd during the northern hemisphere's winter when the Earth is closest to the sun. This is perihelion. okay? And the Earth is furthest away from the sun on around July 4th, our summertime, which is known as ephelion, okay? Um, so because the Earth is closest to the sun during the southern hemisphere's summer, uh, the summer in the southern hemisphere receives more sunlight, more energy from the sun than the northern hemisphere does during its summer. So southern hemisphere summers are basically warmer, you might say, than the northern hemisphere summers. Um, right now, um, the Earth's orbit is becoming less elliptical, less eccentric, if you will, more of a perfect circle, and the tilt is decreasing. Okay, so that's sort of the direction we're heading. Now you notice these cycles again occur on different time scales, about 100,000 for the orbit, 41,000 for the tilt, 22,000 for the wobble. So they don't all coincide, and so that kind of is what gives us these extremes. Um, you'll, for example, have colder periods, particularly in the northern hemisphere, when the northern hemisphere is finding itself at its maximum tilt away from the sun, and when the furthest distance from the sun falls in the northern hemisphere's wintertime. Those again will tend to give you colder weather and potentially even glacial periods. Whereas during the warmer periods of the Earth, particularly in the northern hemisphere, you'll have less tilt, and the northern hemisphere will find itself closest to the sun during the northern hemisphere's summer. Um, so that's the primary natural phenomenon that causes climate to change over long periods of time. Now, in a little bit, we'll talk about um, the things, the activities that people do, that modern society that um, um, appears to be modifying or changing the climate more so than it would occur naturally. All right, but that's for another video.